Plug-in hybrid electric vehicles and electrical infrastructure. Plug-in hybrid electric vehicle is another type of emerging vehicle, which is the combination of alternative fuels to displace the oil consumption in the conventional vehicles. The plug-in electrical vehicles are special type of hybrid electrical vehicles. Similar to hybrid electric vehicle, these plug-in hybrid electric vehicle integrate the electric power path with the mechanical power path by using both the IC engine and electric machines. So plug-in hybrid vehicle have the two power sources, IC engine and electric machines. The very important characteristics of this vehicle is that they can be charged directly by plugging the wire into the grid, so they can be charged from the grid. The difference between plug-in hybrid electric vehicles and hybrid electric vehicle primarily lie in the battery capacity and recharging methods. So the plug-in hybrid electrical vehicles are equipped with large battery capacities that are capable of operating on battery power alone for a longer range or for a considerable range. Then we can call it as all electric driving range. So a hybrid electric vehicle can provide a long driving range because of the large battery size. Also, they differ from the hybrid electric vehicle as they can be charged from the grid and there is the external charging facility. Different types of plug-in hybrid electric vehicles and conventional vehicle comparisons. The comparison can be done based on the stop and start cycle, regenerative braking mode, motor assistance, electric driving mode, and external battery charge. The conventional vehicles, that is the IC engine vehicles, there is no start stop facility. There is the AG start and stop. Regenerative braking is not possible in the conventional vehicles. There is no any motor assistance as there is only IC engine. The electric driving is not available, so there is no any electric driving. The external battery charging, as there is no battery, no external charging. Now, the another type of hybrid electric vehicle is the micro hybrid, where start and stop is possible. A minimum level of regenerative braking can be obtained there, but again, there is no direct motor assistance. Also, there is no electric driving and external battery charging is not possible because it is a hybrid electric vehicle, so it can be internally charged by the IC engine. The next type is mild hybrid electric vehicle. They also have the start and stop facility. Now, the regenerative braking is possible in mild hybrid electric vehicles. There is a small motor assistance there into the vehicle, but again, it is not possible to go for the electric driving mode, and there is no external battery charging facility. Full hybrid electric vehicles, there is start stop facility. Regenerative braking is quite possible. There is also motor assistance, means the motor can run only on the electric mode also, and there is electric driving also. But in the hybrid electric vehicles, there is no external battery charging facility. So in all above, conventional, micro, hybrid, mild hybrid, and full hybrid, there is no external battery charging. And the last type is the plug-in hybrid electric vehicle, where the most important there is external battery charging as compared to all above methods, all above types. Also, there is electric driving, motor assistance is there, and regenerative braking is possible with the start and stop facility. Functions and benefits of plug-in hybrid electric vehicles. The plug-in hybrid electric vehicles combine the function of both hybrid electric vehicles and electric vehicles in a large sense, running both on electricity and petroleum fuels, that is, it is working on the IC engine. Large battery capacities enable the plug-in hybrid electric vehicles to operate in all electric mode or completely in the electric mode as much as possible. And because of this, the fuel consumption is reduced with the use of cheaper and cleaner electricity because electricity can be used to reduce the fuel consumption. Plug-in hybrid electric vehicles have been mainly developed to deal with the three emerging issues in the vehicle transportation sector: the fossil energy security, vehicle air pollution, climate change due to greenhouse gas emissions. So all these things can be achieved using the plug-in hybrid electric vehicle so that energy security can be there, vehicle pollution will be reduced, and the climate change concerns or greenhouse gas emissions also can be reduced. The benefits of plug-in hybrid electric vehicles. The first is petrol consumption reduction. So as discussed, as there is a support of electric propulsion, the petroleum consumption is reduced. The all-electric range or the pure electric driving range enables the switch from using conventional petroleum energy to the electrical mode, that is electricity, which can be generated by various forms of sources, like, for example, battery. This significantly reduces the dependence on the conventional fuel energy transportation sector and provides a wide range of choices to charge the vehicle by generating electricity from renewable energies like wind energy and solar energy. A US National Laboratory report found that 45% of fuel reduction can be obtained by replacing the conventional vehicles by plug-in hybrid electric vehicles with a 35-kilometer of electric travel range. The second benefit is emission reduction. As discussed, because of the use of the battery mode, the petroleum consumption is reduced. Vehicle emissions due to the burning of fossil fuels are remarkably reduced, which is the very important benefit of PHEVs. Centralized generation of electricity and the use of renewable energy sources contribute to significant emission reductions. Plug-in hybrid electric vehicles typically work in the electric-only range that requires minimum engine operations. Emissions may increase at the beginning of the engine start due to frequent multiple engine cold starts. Methods and control algorithms solve such problem so that the overall emissions of the plug-in hybrid electric vehicle can be reduced at a lesser level as compared to the conventional IC engine vehicles. The third benefit is energy cost saving. Besides the fuel consumption and emission reduction benefits, the plug-in hybrid electric vehicles can also benefit from the much lower energy cost. The exact cost saving depends on both the long-term fossil fuel prices and electricity prices. It is estimated that fuel cost per mile of electricity is one quarter to one third of the cost per mile of fossil fuels for PHEV owners. Meanwhile, governmental green energy incentives and certain privileges to lower auto insurance compensate for the higher initial cost of PHEVs. So these incentives, subsidies, they support for the cost reductions and promoting the cost saving also. The fourth one is maintenance cost saving. As the mechanical components such as transmission and clutches are downsized and less frequently used, there are relatively fewer maintenance requirements compared to conventional vehicles. Reducing the use of engine also extend the engine life and reduces the frequency of oil changes. Due to the regenerative braking, there is less friction wear on the mechanical brake, thus reducing the cost of frequently replacing the brake pads. So the maintenance cost is saved because of various reasons. The next is vehicle to grid benefits. Plug-in electrical vehicles have the ability to supply power back to the grid where they are connected to the grid. This serves to maintain the stable grid power level and reduce power ripples. So this is the important benefit that the vehicle battery can supply back to the grid when it is not propelling the motor or motor is not, the vehicle is not in the working condition. Plug-in electric vehicles could potentially serve as temporary backup power source for home uses also when the grid power is not available. The next benefit is customer benefits of home recharging. The plug-in hybrid electric vehicle owners enjoy the benefits of charging their vehicles in their garages or near their homes instead of going for the public charging stations. And that is the reliability. That is the simplicity of the system. Also provide benefit of charging the vehicles at night when the vehicles are typically not in use and the electricity rate is at the cheapest. So they can charge at off-peak hours when the rates are lesser, and also they can discharge to the grid with the higher rates, and also they can earn money or they can benefit. The components of PHEVs. The main components of the plug-in hybrid electric vehicles can be seen as the battery, the electric machine, the engine, and the power electronic system. The battery. Batteries serve as the major energy source in plug-in hybrid electric vehicles. Increased portion of electric power system and the desired all-electric driving range or pure electric mode. Large quantities of batteries with sufficient energy capacity and power density are required in the plug-in hybrid electric vehicles. So the battery is the major component. The battery should be capable of supplying all the power required to propel the vehicle for the entire speed range. And it should have sufficient energy capacity to sustain the desired or required all electric range or pure electric driving range. Battery also needs to provide all power to the accessories such as air conditioning, power steering unit during the all electric driving range. Thus, higher battery performance is demanded by plug-in hybrid electric vehicles. Overall vehicle weight and manufacturing cost are based on the amount of battery. Large quantities of onboard vehicle batteries bring safety concerns about the fire hazards or high voltage short circuits in either normal vehicle operations or accidents. So the costs are based on the battery size, and also the battery can have some hazards or fire hazards. So the safety of the battery and safety precautions are important. So battery plays the most crucial role in developing plug-in hybrid electric vehicles with regard to performance, cost, reliability, and safety concerns. There are various types of batteries. A few can be seen as lithium-ion batteries. They are most widely used in the plug-in hybrid electric vehicles. They provide high energy density and high power density so that for the same weight of the battery, they enable longer all-electric driving range and better vehicle performance. They also have low self-discharge rate that reduce the charging frequency and perform better under low usage rate. Because of the self-discharge, the battery remains for a longer time, though it is not used or in the idle condition. To operate lithium-ion batteries in a continuous, stable state, well-designed battery management system and battery cooling systems are required. So BMS is the important thing when we consider the batteries. Specific conditions such as vibration, humidity, overcharge, short circuit, weather conditions, and water immersion should be taken into account while designing and manufacturing the batteries. Despite the high price, lithium batteries dominate the plug-in hybrid electricity market due to their high performance. The top three best-selling PHEVs currently are, for example, Chevy Volt, Toyota Prius plug-in hybrid, and Ford's C-Max Energy, and all these use lithium-ion batteries, for example. Another battery can be taken, for example, is nickel metal hydride, that is NiMH batteries. They are another type of commercialized batteries that has been implemented into plug-in hybrid electric vehicles. Nickel metal hydride has comparatively high power density and energy density, which is a major requirement of any power source for the electric vehicles. Nickel metal hydride batteries operate in much more stable state, that is abuse tolerant compared with lithium ion batteries. So they are not exposed to various type of problems or faults that is called as abuse. So there is not impact of mechanical abuse, thermal abuse, or electrical abuse. It also has much longer life cycle than lead acid batteries. Nickel metal hydride batteries mostly used as the energy source for the first generation electric vehicles developed before 2005, such as Toyota Prius and Ford Escape hybrid. However, nickel metal hydride are gradually replaced by lithium-ion batteries as the technologies are getting better and the cost effective. The second major component is the electric machine. Electric machines serve as the primary movers in plug-in hybrid electric vehicles to output speed and torque to the output shaft that are connected with vehicle wheels. Regenerative braking is also achieved by running the electric machine in generating modes so that the kinetic energy is recovered from the electric machine into batteries. Electric machine is the only power source to propel the vehicle in all electric driving mode. Hence, a higher power rating is required for electric machine so that it can meet the required torque and speed. For example, General Motors Chevy Volt is capable of 35 miles of all-electric driving range in which all propulsion power and accessory power come from the onboard electric machine that outputs the peak power of 111 kilowatt and peak torque of 370 Newton meter. Second electric machine is utilized to serve as a generator when there are two motors or two machines and engine starter. The second electric machine can also operate in the motoring mode. Currently, interior permanent magnet machines, that is IPM, is the most popular choice for traction drive application due to its high efficiency, high torque density, and high power density. The power density of electric machines in a vehicle propulsion application is about 1.2 kg per kilowatt at the current stage. Research is still going to increase the power density of electric machines to further reduce the size and increase the power. The targeted power density of electric machines for traction drive in 2020, published by the US Department of Energy, is 1.6 kilowatt per kg, requiring 33% increase on electric machine power density within next 5 to 7 years. The next component is engine. Similar to hybrid electric vehicles, plug-in hybrid electric vehicles are also equipped with onboard internal combustion engines. The engines applied differ by the configuration of PHEVs. If the engine is connected in series with the electric machines, so it is the series hybrid, series plug-in hybrid, the electric machines serve as prime mover, prime mover to the supply the majority of power, and engine only functions to support the electric machines or charge the battery to extend the PHEV range. So in series plug-in hybrid, the engine supports the electric machine. Thus, the size and power rating of the engine can be minimized, and high engine efficiency is required at constant operating regions. The another mode can be the parallel mode when engine output power in parallel with the electric machine. The engine is responsible for substantial portion of power demand from the powertrain. Thus, the engine should still retain its power and size accordingly based on power ratios in PHEVs between mechanical and electrical power. In some plug-in hybrid electric vehicles with large battery packs, the engine only serves as backup when the battery is depleted so as to extend the driving range and reduce the range anxiety of the customers. Engine in PHEVs may also apply different technologies compared with engine in conventional vehicles. So Atkinson cycle is used instead of the conventional Otto cycle in some of the PHEVs to further improve the vehicle efficiency. The Atkinson cycle allows the engine intake, compression, power, and exhaust strokes that all happen in one revolution of special design crankshaft. The next components, the PHEV are the power electronics component. They include the inverter, DC to DC converter, charger, BMS, which also typically come along with the battery systems. Inverter serves to transform the DC power from the batteries into AC power, or it can have the AC to AC, AC to DC of various conversion stages. It is also necessary to retrieve the regenerative energy from the electric machine back into the battery pack by using the motor drive components. Inverter and associated controller are typically needed for the onboard air conditioners that use AC machines. Multiple DC to DC converters are used to step up and step down the voltages at different levels. A boost converter is used to increase the DC bus voltage up to a high level from the voltage of the battery pack, which is designed for the electric machine so that the constant torque region is extended and high power and higher speed can be obtained at the rated open point. So this is the summary of the components of plug-in hybrid electric vehicle: battery, electric machine, engine, and power electronics.